So notice, if you want to find your children, you can do some easy math. Multiply your index by 2 and then add 1 to find the second child, the right child. Likewise, if you want to find your parent, what do you have to do? Pick any node on here. Let's say, what is the parent of this node? How do you find the parent of this node mathematically?
Looks like divide by 2 and seal it. So math.seal on it.
Floor, actually, you're doing an integer divide. You just need to do an integer divide. You actually don't have to do any operation. You just divide it, and because you're dividing integers by nature, it's integer division. So 9 divided by 2 in Java is 4, right? 9 divided by 2 is 4. So you look at position 4, that's the 50. Sure enough, 50 is the parent of 65. So you see how easy it is to now say, where's my left child? Where's my right child? Where's my parent? It's a tiny mathematical manipulation to find that. What other operations are interesting? Where does the next child have to go? On the tree, we know it has to go here, right? To keep the tree complete, it has to be the left child of 60. Where does it go in the array? You don't even have to do math. Where does it go in the array?
The next null spot.
The next open spot. And it's not even going to be null. It's going to be, you're going to keep a size variable, and you're going to know based on the size variable where it needs to go, and you're going to increment size, right? So literally, it just goes at the next available spot and size gets incremented. That's easy, right? How do you find the root? It's at index 1. How do you find the last child? It's at index size. Couldn't be a lot easier. Now, writing the code for it can get tricky, because if you're doing all of this math while you're writing the code, it can get very confusing. And if you just look up random code for heaps on the internet, some of them can be very confusing. I'll give you a link to some that I think are more readable, and this is what they do to make themselves more readable. They write some little helper methods. The methods don't do anything very exciting, but they really make life easier when you're reading the code. For instance, if you want to find the parent of a particular thing at a particular index, you call the parent and pass that index, and it just does that integer divide and returns that. So you can find the parent of a given node. If you want to find the left node, call left child, pass the index, and it'll multiply by 2. The right child times 2 plus 1. You want to find out whether a node has a parent? Well, if your index is greater than 1, you have a parent, because there's a root, right? So that's easy. If you have to find out whether something has a parent. Do you want to find out whether there is a left child? If so, you can do a little bit of a quick compare and find out whether there is a left child to this thing. Use size to help tell you. And you can find out if it has a right child in a very similar way. So once you have these helper functions, I'm going to show you a little code, but it's not critical that you memorize it or something. I'm just showing you that once we understand and have these helper functions, we have some reasonable way of approaching this code given our understanding of the algorithm. So for instance, for the add operation, what do we need to do? We're going to plop it at the size plus 1 position, right? Because we use that offset starting at 1, so obviously we're putting it at size plus 1. So you plop it where it has to go, and then you do the sift or bubble up operation, right? You keep looking while you haven't found a home for it. So while you haven't found a home, and in fact, this thing has a parent, because once you get to the root, it doesn't have a parent, so you stop. So while you haven't found a spot and there is a parent to this node, find the smaller of the two children, right? This looks at, right? You find the smaller of the two children. Sorry, we're doing sift up. We're not finding smaller. We're just looking at the parent and seeing whether we need to swap with the parent. If so, swap those two. And then your index for your next check is now the parent, because now you have to sift up, right? So now you're starting at that point. And then you keep looping until you either find the right spot or you run out of road by hitting the root. Either way, you exit the loop, right? And you increment size. So the code is more than I'm asking you to know, but it's not impenetrable once you understand the algorithm. Once you know how to sort of move the things around and understand the sifting up, the algorithm is not impenetrably hard to understand once written into code. Now replace all these helper methods with math, and now it's hard to read, right? If you take every has parent and parent call and things like that, and you remove them and replace them with math, it's a lot harder to read it, but that's sort of unnecessary, right? Any questions about that, folks? So I'm not asking you to know